Shake Table Lab by Alex Peters and Jordan Lee. We made the sketch in the application Sketch. We made sure to add the measurements of the building to create a precise sketch. Each story had to be at least 18 centimeters and the total height had to be at least 36 centimeters. The first thing we made sure to do was construct a square base and support beams. To ensure that our support beams could be an efficient beginning structure to our tower, we made them 2 straws thick. Next, Jordan and I connected the support beams with straws in which we adjusted the size of to connect the beams. We made the straws smaller so we could have a bigger base than the roof. This method has proven to be very strong. Our next step was to make cross supports on each side to protect the building from collapsing and to increase its strength. We made the cross supports by cutting and adjusting straws to fit the area we had to put them in. Each side had 2 cross supports, one on the first floor, one on the second. In total, we had 8 cross supports. We finished the tower by completing another floor, support beams, flags, and other artwork. The floor we completed with construction paper to increase the strength. The support beams we added mainly went from the base to the first floor in a diagonal fashion. We did this to increase the number of sandbags and total weight our tower could support. We added the flags and other artwork to add decoration and a fun spirit to our tower. Similar to the building sketch, Jordan and I added the measurements to the construction sketch using the application Sketch. The only difference was this time we were applying the measurements to the real tower over a sketch of the building. Each story had to be 18 centimeters and the roof was 23 centimeters, which made the total tower 56 centimeters. For static testing, Jordan and I put 4 sandbags on each floor, which tested the strength of our tower and how much weight it could hold. Both floors were successful in holding 4 sandbags each. To strengthen our tower, Jordan and I inputted beams to support our stories. We would put a straw that we adjusted to fit the circumstance going up from the center of the ground floor to the bottom of the second floor. This would improve the amount of weight and sandbags that our tower could hold. We agreed that our tower's strongest part were the support beams going up from the ground level to the second floor. Jordan and I constructed 4 of them and put 1 in each corner. Due to the support beams, the second floor became very sturdy and one of the strongest components of our tower. Jordan and I thought that our tower's weakest part was the 3rd story. We thought this because it wasn't nearly as strong as the second floor. It wasn't as strong as the second floor because we only put 2 support beams on the 3rd floor to our 5 support beams on the second floor. We surely did use a bit too much tape. We decided that even though most corners may look like rat nests, the tape still increased the strength of our tower and made the straws less likely to give out. Our extra supplies consisted of construction paper and colored markers. We used the construction paper for the flooring and the flags for the roof. To seal the construction paper onto the floors, we used tape. The colored markers came into use when we drew designs on the flags for the roof. This shake table video shows Jordan and I's tower surviving 12 sandbags.
Please, just survive.
Dude, this tower is strong. It's not even bending. This shake table video shows Jordan and I's tower failing at 22 sandbags. Our tower failed because there was a lot of weight on it. 22 sandbags is equivalent to over half a brick. Jordan and I's tower held 20 sandbags. Therefore, our tower had many sensor graphs. This graph or sensor reading shows the point of the tower's failure. The x-axis represents the side-to-side motion, the y-axis represents the forward and back motion, and the z-axis represents the up and down motion. Hello, my name is Alex Peters, and Jordan and I's tower held a total of 20 sandbags, when each sandbag weighs 250 grams. So in total, our tower held 5,000 grams. Our tower failed in the bottom right corner because a lot of the sandbags' weight on the second story and the third story ended up compressing on these single supports. If I could have changed anything, I would have added more straws to support up the first floor because most of the weight ends up compressing on the supports. What I learned about building an earthquake-proof tower is that you absolutely need cross supports. And the more cross supports you have, the more sturdy and more reliable your tower is going to be. What I enjoyed about doing this lab is working with my friends and coming up with new ideas to build an earthquake-proof tower. Thank you.
Hello, my name is Jordan Lee. Our building supported 20 sandbags. Each sandbag weighed 250 grams, so our building held a total of 5,000 grams. Our building failed where the bottom supports were because there was so much weight on the second and third floors that there was so much weight on the bottom supports that it eventually fell. If we had 4 extra straws, we would have put supports on the bottom floor so that it would have held up the weight on the second and third floor. And it would have helped our structure be more stable. I learned that earthquake-proof buildings have X supports, which keep the floors up, and a very sturdy base so the building would not fall. What I enjoyed about this lab and building this structure is that I enjoyed working with my friends and coming up with new ideas about building a new building.